Good day, everyone. Today we will discuss about theory of relativity. The theory of relativity was developed by renowned scientist Albert Einstein in the early part of 20th century. It actually consists of two theories. First is the theory of special relativity, and the second one is the theory of general relativity. But for today, we will focus about our topic, the theory of special relativity. But before of that, I am Palima Mary Christ. I will discuss about the special relativity. The theory of special relativity means that events can occur at different times, but depending on the person's location or point of reference. For example, if a person drops an object from a top of the building, the trajectory of the object will be different for someone standing directly above the object or for the person watching from a distance. Therefore, the fact of the events are seen as simultaneous by observer appear separate in time in a different observer's frame of reference. In simple terms, the theory determines that the laws of physics are the same for non-accelerating observers and shows that the speed of light within a vacuum the same no matter the speed in which the observer travels. For the next discussion, here is Mr. Lalimarmo will explain the first postulate.
The first postulate of special relativity, also known as the principle of relativity, states that the laws of physics are the same in all inertial reference frames. An inertial reference frame is a frame of reference that is not accelerating but moving at a constant velocity. In other words, there is no preferred or absolute frame of reference. This postulate implies that the fundamental laws of nature, such as the laws of motion, electromagnetism, have the same form in all inertial frames. Observers in different inertial frames will measure the same physical phenomena and obtain consistent results when performing experiments. Example: Imagine two observers, Alice and Bob, who are moving relative to each other in outer space with a constant velocity. Alice is inside a spacecraft and Bob is outside. The observing Alice spacecraft from a different reference frame, they both have clocks and measuring devices. According to the first postulate, the laws of physics are the same in all inertial reference frames. This means that Alice and Bob should observe the same physical phenomena and obtain consistent results when performing experiments, despite their relative motion. For instance, let's say Alice performs an experiment involving the behavior of light inside her spacecraft. She measures the speed of light using her equipment and performs other optical experiments. At the same time, Bob, who is stationary relative to his own reference frame, observes Alice's experiments from his vantage point. Due to the constants of speed of light, as described by the second postulate of special relativity, both Alice and Bob will measure the same value of the speed of light, regardless of their relative motion. This result is consistent with the first postulate, which ensures the law of the physics, including the behavior of light, are the same in both inertia frames.
The concept of second postulate could refer to the different things, depending on the specific context. Here are the few possibilities. In physics, there are few different things that could be reflected as the second postulate. It may refer to the second postulate of special relativity, which states that the speed of the light is always constant regardless of the motion of the observer or the source of the light. It could also refer to the second law of thermodynamics, which states that the total entropy of a closed system will always increase over time.
In other contexts, such as philosophy or mathematics, the term second postulate could be used to refer to any fundamental principle or assumption that is considered to be the second in a series or sequence of important ideas.
Time dilation is the slowing of time as perceived by one observer compared to another, depending on their relative motion or positions in a gravitational field. Time dilation happens when there is a difference in speed or gravity between two different observers. For example, there are two observers in illustration. One observer is on a moving train and the other one is standing by on a waiting shed. The train is between two electrical posts on both ends when lightning suddenly strikes. The observer on the waiting shed sees the lightning strike at the two electrical posts at the same time, while the observer on the train sees the lightning strikes in different times because of his movement and frame of reference. And for the explanation of length contraction, I will introduce Ms. Nikki Lorenzo.
Length contraction. An object seems to be contracted when traveling at relativistic speeds according to equation. One of the peculiar aspects of Einstein's theory of special relativity is that the length of object moving at relativistic speeds undergoes a contraction along the dimension of motion. This phenomenon is not due to actual error in measurement of faulty observation. The object is actually contracted in length as seen from a stationary reference frame. The amount of contraction of the object is dependent upon the object's speed relative to the observers.